I'm asked to do a whole bunch of things here in 12.3, number 4, starting with these two vectors u and v. And I think that u comes before v in the alphabet, so I like to write u's before v's, as opposed to some textbook authors. Okay, so if this is u and v, then, well, one of the things I'm asked to compute is u dot v, the sum of the products of the components. So the first component of u times the first component of v plus the second component of u times the second component of v plus the third component of u times the third component of v. All right. Well, that's easy enough to calculate. Negative 25 I get. Okay. Magnitude of u, we did this before. Sum of the squares of the components square rooted. And that comes out to 5. And boy, I just keep encountering the same numbers. V similarly has a magnitude of 5. Now what's new to section 12.3 is the idea of an angle. Oh, well, besides the dot product. The idea of an angle is new in this section. The angle theta between u and v is defined by the expression cosine of that angle is u dot v, which is simply a number, divided by the magnitude of u times the magnitude of v, which in this case is negative 25 over 5 times 5, which is negative 1. Oh, you know what? I bet you. So what angle theta has? Cosine theta is negative 1. That's arc cosine of negative 1. Cosine is the x-coordinate on the unit circle, so I'm thinking pi. But that angle is not what's being asked for here. Rather, part B says, find the cosine of the angle between u and v. Awesome. I'm done. Now, C, for C here. The scalar component of, let me copy it carefully, u in the direction of v. Okay, so the direction of v, I remember from the last section, is 1 over the magnitude of v times v. Okay, and so, oh man, I really ought not use that dot symbol right there, right? Because there's a cross product now that you have to worry about it. Just I'm going to do that. Ooh, and it's especially good because the scalar component of u in the direction of v actually is u dotted with the direction of v. Let me think about that. Oh, I already know what the magnitude of v is. That's 5. 5 times u dot v. Oh, which u dot v I also have computed. So that is negative 25. And 25 divided by 5, that's negative 5. Okay, so that is to say that geometrically u has a part pointing in the direction of v of magnitude negative 5. Okay, what's that last part? The projection. 4D. I'm supposed to get not the scalar projection this time, but actually the projection of u onto v. And the projection, of u onto v. I always think of it this way, like v is the guy below, so you're projecting onto him. That's my mnemonic for who to put where. That is, let's see, first you take that scalar projection and then you simply say that you've got that quantity going in the direction of v. So that is to say you take that scalar that we just calculated. Right, we just calculated that. It's a scalar. Let me put it in parentheses. And that scalar is going to be the magnitude on the vector 1 over v. Now, every time I've ever written this in my entire life, it has looked weird. Oh, sorry, 1 over magnitude of v. Because there's just so many v's floating around. But it's the right thing to do. See, this is the direction of v right here. You find the component of u in the direction of v, and then you multiply it by the direction of v to get the projection of u onto v. Let's see, that's negative 5 times 1 over 5 times this, oh, you know what, that's just a negative 1. At any rate, v was 2 negative 4 square root of 5, and since we've just got a negative 1 there, that'll give us negative 2, 4, negative square root of 5, which is equal to, I mean, this is, I've seen this before, it's u itself. Oh, interesting. I wonder why that is. I think you should draw a picture and think about why that is. Now, if the angle between these things is pi, pi translates to 180 degrees, they're pointing in opposite directions. So the projection of one onto the other is the other. The projection of u onto v is simply u. Boy, what is that? Okay, look, I got a little bit of room over here, assuming I don't put my face over there. Let me just draw it. Here we could say is u, and then v in the opposite direction. How do you project u onto v? Well, it's the part of u that lies along the line defined by v. Oh, it's the whole thing. The projection of u onto v is indeed u.